Okay, this is the notes for Module 8A, graphing points and determining slopes. We're going to complete the highlighted problem starting with number 5, where you're asked to plot the ordered pair 5, -4, and state which quadrant that point is located. So here's your graph. Over here on the left, you have your y-axis that runs vertically up and down, and then you have your x-axis that runs horizontally left to right. When we plot this ordered pair, 5, -4, remember your first point represents your x-coordinate and the second in parentheses represents the y-coordinate. So we will move to 5 on the x-axis, then to -4 on the y-axis. We'll graph the point where those two lines intersect. On the y-axis, I'm going to count over to 5. 1, 2, 3, 4, 5. And then to get to -4 on the y-axis, we move down from this point 4 spaces. 1, 2, 3, 4. So at this point, 5 and -4, these two lines intersect. This would be the ordered pair 5, -4. The second part of the question says, which quadrant or axis does the point lie? Your quadrants are identified using Roman numerals. This is quadrant 1 in the upper right-hand corner, and the upper left-hand corner is quadrant 2. And then moving down, you have quadrant 3 in the lower left corner. And then on the lower right side, you have quadrant 4. So this ordered pair is located here in the 4th quadrant. You would choose Roman numeral 4. For number 6, you're asked to find the x and y coordinates of the point that's labeled. So this time the point is already plotted for you, letter A. We just need to know the coordinates. We want to know where is this point on the x-axis and where is the point on the y-axis. So if you look and see, you'll notice your y-axis and your x-axis intersect at this point, letter A. You haven't moved from that intersection, so you're at 0 on the x-axis, and then you haven't moved up or down on the y-axis, so you're at 0 and 0. So at 0, 0, that point is also called the origin. But you're asked to identify the ordered pair, so you would list 0, 0. Let's move on to number 11. You're asked to complete each ordered pair so that it is a solution of the given linear equation. So you're given this equation, y equals 1/3 x minus 7, and you're really being asked to fill in these two spaces. Notice that those empty spaces are inside of parentheses. So we're identifying those points as ordered pairs where the first space represents the x coordinate and the second one is the y coordinate. And the reason that's important, because we're going to use this information to plug in numbers into our equation. So let's rewrite our equation over here to the side. Y equals 1/3 x minus 7. And for the first ordered pair, you have -9, comma, and then an empty space. For the second ordered pair, you have an empty space, -4. So we have the x coordinate for our first ordered pair. We're looking to find the y coordinate in order to fill in that space. So we would substitute -9 for x into our given equation. So we'll just rewrite the equation and replace the letter x with -9. That'll become y equals 1/3 x, but instead of writing x, remember we're substituting x with -9. So 1/3 times -9 minus 7. And then we'll simplify here. 1/3 times -9. You can even punch this into your calculator. If you divide 1 by 3, you'll get a decimal, 0.3 repeating, and then you multiply that by -9. And what you'll get is -3. and then we'll carry down the -7. So y equals -3 minus the 7. And -3 minus your 7, remember the 7 comes from this space, would give us -10. So our empty space for the first ordered pair next to our -9, the y coordinate, we would replace that space with -10. Now let's look at the second ordered pair. Remember, we have an empty space for x, but you are given the y coordinate. So we'll take that y coordinate and substitute it into the equation we were given. Y equals 1/3 x minus 7, but where y is, we're going to replace -4. So -4 equals 1/3 x minus 7, and we're going to solve the equation for x. To solve this equation for x, we first get rid of the 7. So we're going to add 7 to both sides of the equation. The 7s will cancel on the right side. And on the left side, -4 plus 7 gives us 3 equals 1/3 x. Now, in order to get x by itself, we're going to take the reciprocal of 1/3. So we're going to flip this fraction, remove the denominator to the numerator and the numerator to the denominator. And we're going to multiply both sides of the equation by that reciprocal. When you reverse this fraction, the reciprocal is going to be 3/1 or just 3. And you multiply both sides of the equation by that reciprocal. So we're multiplying both sides of the equation by 3. On the right side of the equation, 3 and 1/3 will cancel each other out, leaving x. And on the left side, 3 times 3 would give us the value of x, which is 9. And 9 will be the value you were replaced into that order pair. Moving on, let's look at number 15. You're completing a table, and when you're completing this table, you're going to do the same steps, very similar to our last problem, except for now we're using a table format. So each of these rows represent an x and a y coordinate. If I were to put parentheses around those numbers, it's an ordered pair. And we're filling in each column with the missing value. So let's look at the first row. We have 0 for x. We want to know what is y when 0 is substituted for x. Now, where do we substitute this value into the given equation? All right, so let's look at the equation we're given. Y equals 2x minus 14. And we want to know the value of y when x is 0. So where x is, we're going to replace 0. That will become 2 times 0 minus 14. On the left side, we have equal sign and y. If I simplify this, 2 times 0, that's just 0. So y is -14. So the first row, we'll replace y with -14. Now let's look at the second row. This time we're given the y value. So we're still using the same equation. Y equals 2x minus 14. And now we're going to substitute -8 for y. So we'll have -8 equals 2x minus 14. And now we'll solve this equation for x. So the first thing we want to do is add 14 to both sides of the equation. Adding 14, remember that's the opposite of subtracting 14. When we add 14 over on the left side of the equation, we have -8 plus 14. We want to combine those two values. And you'll get 6 equals 2x. Continue to solve the equation. We want to divide both sides of the equation by 2. The 2's will cancel. And x equals 6 divided by 2, or 3. So we will replace the second row, our x coordinate, we're replacing that with 3. Now let's look at the last row. Again, we're using our given equation, y equals 2x minus 14. And this time we're given 5 as our x coordinate. So we want to replace 5 for x. That would leave us with y equals 2. And in parentheses, let's replace the x coordinate, which was 5, minus 14. We'll simplify this. So y equals 2 times 5, or 10, minus 14. And 10 minus 14 is negative 4. That's your y coordinate. All right, so now we're done. Let's look at number 16. We're identifying the intercepts. Now that word intercept means where does these ordered pairs, we have 1 point here on the x-axis, 1 point here on the y-axis. And let's just go ahead and write those ordered pairs. I'm looking at my spaces. I see a 5 here, but I don't see numbers representing each of these little spaces. So I just want to count and see that each of these spaces are 1, and they are 1, 2, 3, 4, 5. So that lets us know that our first point would represent 1, 2, 3, and 4. So this ordered pair is at 2 on the x-axis, and you haven't shifted on the y-axis. The ordered pair would be 2, 0, since you didn't move up or down. For the second ordered pair, on the x-axis, you don't move left or right. So it's 0 on the x-axis. But on the y-axis, you move down 1, 2 spaces. That will be negative 2. So that ordered pair is 0, negative 2. Now, what are the intercepts? Your x-intercepts are going to be the point where you cross the x-axis. See how this line crosses the x-axis at 2. This is our x-axis that runs left to right. That means 2 would be the x-intercept. For the second point, the y-intercept would be where this point, where this line goes through the y-axis. So on the y-axis, this point crosses at negative 2. It crosses the y-axis down here at negative 2. So our y-intercept is going to be negative 2. And that's all you have to do for that one. Identify your x and y intercepts. Where does the line go through the y-axis? Where does the line cut through the x-axis? So y-axis, x-axis. Moving on, let's look at number 21 and 22. Now for these problems, you're asked to find the slope. There's a formula you could use to find the slope when you're given 2 points. Now another thing we want to take note of is this letter variable m. We use the variable m to represent slope. And the formula to find the slope when you're given 2 points is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So what we do when given 2 points is we're going to choose our x and y coordinates using 1 and 2. Since I have 2 points and they both have x and y coordinates, you want to make sure you identify your first point and your second point. It doesn't matter the order you choose. So let me rewrite these points over here so you can see this a little bit more clearly. You got 7, 1 and 7, 7. So for my first point, I'm going to label the x coordinate as x sub 1 since it's my first point, and the y coordinate as y sub 1. For the second point, we're going to label our x coordinate as x sub 2. It's the second x coordinate. And the y coordinate you'll label as y sub 2. Now we'll take these values, x1, y1, x2, y2, and substitute those values into the formula. So remember our slope is equal to y sub 2 in the numerator minus y sub 1. What is our y sub 2? It's here, 7, minus y sub 1, which is 1. And in the denominator, x sub 2 minus x sub 1. Our x sub 2 is 7. Our x sub 1 is 7 also. So let's simplify this. 7 minus 1 in the numerator will give us 6. In the denominator, 7 minus 7 is 0. If you attempt to divide 6 by 0 in your calculator, you're going to see an error message or undefined, because it's impossible to divide 6 by 0. So this slope is actually undefined. So you would choose letter B. The slope is undefined. Now what you will learn is, in your notes, perhaps mark a vertical line and a horizontal line, because each of these have special slopes. Anytime you see a graph of a vertical line that runs up and down, then the slope will be undefined. When you plug in the values for the 2 points that you choose, you're going to wind up with 0 in the denominator for any vertical line. So for every vertical line, if you want to mark this in your notes, if you have a picture of the line and it's vertical, then the slope would be undefined. Now, on the flip side of that, if your graph is a horizontal line, then you'll find the slope is 0. The slope would be 0, and this time when you plug in your points, substitute them into the formula, you'll wind up with 0 in the numerator. So it'll look like something like this, maybe 0 over 5. So if you divide 0 by 5, you'll wind up with 0. So every horizontal line has a slope of 0. This is just information that you want to copy in your notes. Now let's look at number 22. You're using these points that are identified on the line to find the slope. So we're using the same formula we used a moment ago. M equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Now our ordered pairs for the first point up here in the second quadrant is -4 on the x-axis and 2 on the y-axis. So -4, 2. Let's just go ahead and make this our x sub 1 and y sub 1. For the second point, we're at 2 on the x-axis, and we're down at -3 on the y-axis. So we'll make these points are x sub 2 and y sub 2, and now we'll substitute these values into our slope formula. So looking at our slope formula, we'll have m equals y sub 2 minus y sub 1, or -3 minus 2. In the denominator, our x sub 2 minus x sub 1, x sub 2 is 2, minus x sub 1 is -4. Let's simplify here. In the numerator, -3 minus 2 gives us -5. In the denominator, 2 minus -4. Remember, those two negatives side by side mean addition, so this will be 2 plus 4, or 6. Our slope is -5, 6. All right, let's move on to number 25. Look, we have a vertical line, and we just talked about the slopes of vertical lines. Any line that goes up and down, your slope is going to be undefined. So undefined is your answer. But let's look at the numbers just so you could see how it becomes undefined. So our ordered pair for this first point up here in the first quadrant is 4, 3. Let's go ahead and make these points our x sub 1 and y sub 1. Our second point down here in the fourth quadrant is at 4, negative 3. And we'll make these points our x sub 2 and y sub 2. So using our slope formula, remember our formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Our y sub 2 minus y sub 1 in the numerator will give us negative 3 minus 3. Which would be negative 6. In the denominator, we have x sub 2 minus x sub 1, or 4 minus 4. So right there you see 0 in the denominator. If you divide 0 or negative 6 by 0, you'll get an error message or undefined. So our slope is undefined. All right, let's look at number 26. Now sometimes you won't have the ordered pairs, you won't have an image of the graph, but you may have an equation. There's a specific formula that involves the slope that we want to be mindful of, and it's y equals mx plus b. This is called the slope-intercept form of an equation. So make sure you have this in your notes. Slope-intercept form. I'm just going to abbreviate intercept. Now, when your equation is in slope-intercept form, you notice that y is by itself on the left side, y equals, and all the other terms are on the right side. So in order for your equation to be in slope-intercept form, you must have y by itself on the left. If the equation is in slope-intercept form, then m, remember m stands for slope, is going to be the number that's in front of x. Whatever number is in front of x is going to be your slope. The number that you are adding and sometimes subtracting behind x is going to be your y-intercept. So in our example, we have y equals negative 3x minus 7. So here, the number that's directly in front of our x is negative 3, so that's our slope. Here, the number that's behind x is negative 7, so negative 7 is going to be the y-intercept. Okay, we're done with that one. Let's look at number 31. So we're asked to find the slope again, but notice this time our equation does not have y by itself on the left. If you don't have y by itself, you have to solve for y. So we're going to rewrite this equation and get y by itself. 8x minus 9y equals 72. First, we want to subtract 8x from both sides. It's positive. The opposite would be to subtract 8x from both sides of the equation. The 8x will cancel on the left. We'll bring down negative 9y equals. And our negative 8x will be first. A positive 72, so plus 72 on the end. And lastly, we're going to divide both sides of the equation by negative 9. The negative 9s will cancel on the left side. On the right side, remember you're dividing every term by negative 9. So negative 8x over negative 9 will give us positive 8 over 9x. Remember, negative divided by negative is positive. And then 72 divided by negative 9 would give us minus 8. So what is our slope? Our slope will be the number that's in front of x, or 8/9. Our slope would be 8/9. All right, let's look at number 33. The pitch of the roof is the slope, and we're going to find the pitch of this roof. Now we're given two values for the pitch. We're given the height of 12 And our length, our left to right, our run of 16. I'm saying height and run because we also know slope to represent rise over run. So rise would be how far up you move. Your run would be how far to the left or right you shift. And in this example, we're going, our rise is 12, we're moving upward, 12. Our run, the shift from left to right, is 16. So it's 12 over 16. However, 12 over 16 can be simplified. So we want to make sure our final answer is in lowest terms. What can we divide into both 12 and 16? We can divide both top and bottom by 4. And when we divide 12 by 4, we get 3. When we divide 16 by 4, we get 4. So 3/4 will be our slope in lowest terms. That's our pitch. Pitch is the same thing as the slope. Now let's look at number 34. The grade of a road is its slope written as a percent. So this time we're going to find the slope, which is, again, rise over run. Which would be equivalent to our rise going up to our run, the left to right is 24. Now this can be divided, both can be divided by 2. So we can simplify this to be 1 over 12. Now we're taking this slope and we're writing it as a percent, which means we're going to take our decimal we have here, or our fraction, because it's in fraction form. We're going to divide it to get a decimal. 1 divided by 12 would get, or 1 divided by 12 would give us 0.083, and the 3 repeats itself. To change this decimal to a percent, you can either move the decimal 2 places to the right, or you can multiply by 100. So we move the decimal 2 places to the right and we'll get 8.3%. So again, our slope, remember, is rise over run. And after you get your rise over run, you want to multiply by 100 to change this value to a percent. But 8.3% is what you get. And that's the end of our Module 8.A notes.